Alright, continuing, we got the weather section next. There we go. So let's try this instead of decoding all that. So here we go. 12:26 at 12:54, 1 p.m. 17 degrees outside, dew point of 11, wind direction from 210 degrees. So that's like from the west at 12 miles an hour. Visibility is 4 statute miles. Altimeter is 30.089 inches of mercury. Sea level pressure is 1020.4 millibars. Sky cover is overcast at 800 feet, but we're going to be less than that. If it was overcast at 400 feet or 300 feet, we couldn't fly. And the pressures is decreasing. So, all that information is actually in here, also cryptic. So I'm going to use this information and type it all over there. So I'm going to pause. Okay, so I took all of the METAR information from here and I typed it in here. We're going to need that a little bit later. And let's see if we can get this. So here's the TAFs decoded, because if we went to here, these are the TAFs too, but you have to decode what all these things mean, and you can see that blue is marginal VFR, red is IFR, but you have to find out what the cloud base is in order, we have to fly in a marginal VFR at the altitude, which is 400 feet or less. So we can use this one, and this will decrypticize it. So we're going to be flying between 2:30 and 4, because we're not going to fly after dark. All right, so wind direction is expected to be 220, 16 miles an hour, gust to 25, visibility 6 statute miles, overcast at 1,500 feet AGL. So I'm going to need to put this information over into our TAF forecast. So I'm going to do that and come back on. Alright, so we filled out the TAF, not within 500 feet vertical, 2,000 feet horizontal. Okay, so at the time we're expecting to fly this afternoon, we're not going to have clouds below 1,500 feet. So we're not going to be within any clouds at all. Visibility is supposed to be 6 statute miles, so we're good. Ceiling forecast, if it's broken or overcast at flight altitude. So it's overcast, but it's 1,500 feet. So we are okay. Now, the drone performance is an interesting thing. So we need to get this information, and then we do some calculations. So the local airport, that's why we need to get this stuff. Where's the airport stuff? Weather, airport. So 670 feet, MSL. Let's put that in here. 670 feet, MSL. Current reported standard pressure. So our current pressure, altimeter, right? Inches of mercury, copy, and that goes down here. Current reported temperature, current temperature is 17 degrees. And now I need to do some calculations. Current reported standard temperature. So just make sure I got the right one here. Right, okay, so we need to calculate standard pressure. So 15 degrees C minus 2 times local MSL, which was 670, divided by 1,000 is going to equal something. Let me do the math. All right, here we go. I'm just going to do it in pieces. 670 divided by 1,000 is 6.67. Right. Multiply that by 2 is 13.4. No, we did something wrong. Let's try again. 670 divided by 1,000, 0.67. Multiply that by 2, 1.34, and that's minus, so it's 13.66 is, so 13.66 degrees C is a standard temperature. Standard temperature is a formal thing that's how they you need that for the equation. So now we need to do pressure altitude. So I'm going to type all this in. Hang on. Okay, so here we go. 29.92 minus the 30.09. That's going to be multiplied by 1,000. And then add all that to the airport elevation of 670 feet. And that's going to equal that. So let's give it a try. Alright, so let's do that. 29.92 minus 30.09 minus, that sounds about right. Multiply that by 1,000 and then add that to 670. So we get 500 feet. So the pressure altitude is 500 feet. And now I need to calculate density altitude. Okay, so here we go. The local temperature, which was 17, minus standard temperature, which we calculated to be 13.66, multiplied by 120, then add the pressure altitude, which was the 500 from up here. So now we need to do our calculator. And let's see, we got 17 minus 13.66 is 3.4, that sounds about right, multiplied by 120. And then add that to 500, so we get 900 feet. 900 feet MSL. So we are, the airport, we're going to be close to it, it's at 670 feet because of the temperature and the barometric pressure. It actually is going to, the drone is going to feel like it is at 900 feet. That's not MSL, it's AGL, isn't it? This is MSL. There you go. Yep. So it's going to feel like it's flying higher, so it's going to have less, has poorer performance. The air is going to, feels like the air is thinner. Not by much, but that's why we do it, to see what kind of performance degradation or improvement happens with the temperature that we have.